All right, so topic for this video is going to be composite area, where we will be attempting to find out how to calculate area for composite figures, or figures that we just straight up don't have a regular old formula for. So our first little part here says to find the area of a composite figure, first separate the figure into smaller shapes that you can find the individual areas of. Afterwards, add the individual areas together to find the sum. Pretty straightforward. We're going to divide and conquer, essentially. Example 1 says find the area of the composite figure, round to the nearest tenth. Cool. So first thing that I spot when I'm looking at this thing is this nice old rectangle here. So let's find the area of that guy. Now, a rectangle is a type of parallelogram, and that formula is base times height. So let's do a little 12 times 8 here, and get 96. And then we'll move on to the other shape, which seems to be half of a circle, a semicircle. Now, there is no normal formula for a semicircle that we saw in the last video, but I think it's safe to assume that we're cool with just doing 1/2 pi r squared, or pi r squared divided by 2. Now, the radius of that we don't see right away, but the radius should be half of the diameter, and the diameter is 12 by looking at the other side of the rectangle, so the radius should be 6. So we will do 1/2 times pi times 6 squared. And that's going to give us 56.5. So we found the area of the rectangle, we found the area of the semicircle. So now let's just do 96 plus 56.5. Type that into my calculator here. And I'm getting 152.5 inches squared. So pretty straightforward. Just find the areas of the individual shapes and then find the sum. Our next example, looks like we got a little parallelogram and a triangle here. Let's start off with the parallelogram. Now, parallelograms have formula of base times height. So I'm just going to be doing 16 times 12, because 12 seems to be the vertical height there. 16 times 12 is going to be 192. So that's our parallelogram. Now let's look at the triangle. Now for the triangle, we need to do 1/2 base times height. Our base is definitely the 16, but we don't have the height. So let's take a quick time out and do the Pythagorean theorem to find the height. That's going to be a squared plus b squared equals c squared. That'll be x squared plus 16 squared equals 20 squared. It'll be x squared plus 256 equals 400. If I subtract the 256, I'll get 144. So the height of our triangle is 12. So we'll do 1/2 times 16 times 12. And that should give us 96. All right, so for our total sum here, we're going to do 96 plus 192. And I'm going to get 288. And that'll be centimeters squared. So once again, just dividing and conquering, right? Find the areas of the individual shapes, then find the sum. All right, going to the inside. What do we have here? We got something pretty wacky looking here, don't we? So it looks like we got these two triangles with kind of a square or a rectangle looking thing in the middle. I'm just going to go ahead and start off with the little rectangle in here. Now for rectangles or squares, any sort of parallelogram, our formula is just BH, base times height. And this looks like it's going to be 8 times 6, which is 48. So good start. Now let's find one of our triangles. Triangles are 1/2 base times height. Looks like our base is the 20. But how do we find this height? Well, we know that the entire way from like this tip all the way to that tip to the other side is 30. So if I do 30, that's not 36, sorry. If I do 30 minus 6, I get 24. So this 24 here would be this part and this part, right? Because I've taken away the 6 in the middle. So then if I do 24 divided by 2, I'll get 12. So the height of our triangle is going to be that 12. So I'm going to do 1/2 times 20 times 12, which should be 120. Now I should be able to do the exact same thing for the other triangle. So that would be 1/2 times 20 times 12 to also get 120. And then I'll just need to do 48 plus 120 plus 120. And that is going to give me 288 centimeters squared. Pretty crazy. I think that's what we got on the last one. Okay, what about this guy? So this is find the area of the composite figure round to the nearest tenth if we need to. Okay. So it looks like we got a trapezoid and a triangle. Let's start with the trapezoid. Now for the trapezoid, trapezoids have a formula of 1/2 B1 plus B2 times the height. So let's see what we have here. We do have one of the bases, it's 18. We don't know what the top is. We do know that the height is 14. So we're in a little bit of a pickle already because we don't know what the top base of our trapezoid is. So maybe let's look at the triangle. Maybe we'll come back to that. Let's see if we can get anywhere in the triangle. Triangle is 1/2 base times height. Looks like we're in a similar situation because we don't know the base of the triangle because that happens to be the same side as the trapezoid. Do we know what the height of the triangle is either? No, we sure don't, do we? We're really in a pickle here. So what other information do we have that might be beneficial? We do have the 16, which is one of the kind of legs of this triangle. And we do have that 30-degree angle. Now all of a sudden my mind's thinking about that 30-degree angle because that's making this triangle, this blue triangle, into a little 30, 60, 90 triangle. Now if that's a 30, 60, 90 triangle, the 16 is the hypotenuse, which means, let me just call this x and this y. X is the short leg, which means that x should be the hypotenuse divided by 2. That's our 30, 60, 90 rule. So that means that x is 8. So the height of the triangle is 8. Now, if the short leg is 8, that means that the long leg would be 8 times root 3. That's the other 30, 60, 90 rule. And 8 times root 3 is just 8 root 3. And since that's being marked as the same as this side, that means that the base of our triangle is 16 root 3. And that means also that the other base of our trapezoid is 16 root 3. So that's why this thing said round to the nearest tenth, because when we typed all this in, we're definitely going to get some decimals. Let me go ahead and find the triangle because I was doing that most recently. I'm going to do 1/2 times 16 root 3 times 8. And I'm going to get 110.9. And now let me do the trapezoid. I'm going to do 1/2 times 18 plus 16 root 3 times 14. And I'm going to get 319.98, so I'm just going to say 320 if we round to the nearest tenth. Okay, that one was tricky. So 320 plus 110.9 is going to give me 430.9 centimeters squared. Okay, had to do a little 30, 60, 90 in there. That was good. All right, let's go to the last ones here. Okay, this one is our first one that says find the area of the shaded region. So for this one, what we're going to do is we're going to find the area of the big shape and then subtract the area of the square in the middle. So big shape looks like it's either a kite or a rhombus, probably a rhombus. But either way, we have the same formula for those. So for this guy here, for the big shape, we are going to do 1/2 d1 d2. So that would just be 1/2 times 6 times 10, which would be 30. Now let's look at the square in the middle. So square in the middle, if it's a square, it's got the formula just base times height because it's a parallelogram. And, well, one thing we learned about in previous video over special parallelograms is that in a square, it's divided into a little 45, 45, 90 triangle. So that means that if I want to find, for instance, one of the legs, if I just put an X there, I know that the leg is supposed to be the hypotenuse divided by root 2. And if I take 4 root 2 and divide by root 2, I just get 4. So that's going to tell me that all the sides of this thing are 4. So I'm just going to do 4 times 4, and I'm going to get 16. So instead of adding the composite, the individual shapes on this one, if you've got this area, the shaded region type question, you are going to subtract them. So this is going to be 30, that looked like a 36. This is going to be 30 minus 16 to get 14 centimeters squared. And our last one says find the area of the shaded region. We've got a hexagon inside of a circle. Okay, let's try to find the area of the circle, I suppose. Area of a circle is pi r squared. Now, we're immediately faced with a problem because we certainly do not have the radius of this thing. We have the apothem of the hexagon, but that is not the radius. So I'm going to suggest that we draw the radius going this way, because that'll be twofold. That will be the radius of the circle, and it'll be the radius of the hexagon, which we're going to need. Now, we still don't know what that is, but we can find it, because remember that formula 360 divided by 2n, where n is the number of sides? That's the formula that we use to find this angle formed by the apothem and the radius. And if we do that for a hexagon, we get 30, which is convenient because that makes a little 30, 60, 90 triangle right in here. And if the apothem, if the long leg is 2 root 3, that means that the short leg, like if I just call this x right there, that means that the short leg is going to be 2 root 3, the long leg, divided by root 3. 2 root 3 over root 3 is 2. And then if the short leg is 2, then the hypotenuse is the short leg times 2, which is 4. So the radius of our circle, the radius of our hexagon, is 4. So let's do pi times 4 squared. And I'm going to get 50.3. Now what we need to do is find the area of the hexagon, and then we can subtract them, and we win. Now, a regular polygon's formula is 1/2 AP. So this is going to be 1/2 times the apothem, which we've had from the very beginning, which is 2 root 3, times the perimeter, which we do not have, but we can find. Because if that little short leg of the 30, 60, 90 triangle is 2, remember the apothem also splits that side in half, so the other side's also 2. And 2 and 2 tell us that every single side on this hexagon is 4. So our perimeter should be 6 times 4, which is 24. So to find the area of the hexagon, I'm going to do 1/2 times 2 root 3 times 24, and I'm going to get 41.6. So I will do the circle, 50.3, minus the hexagon, which is 41.6. 50.3 minus 41.6, and I'm going to get 8.7 centimeters squared. Ooh, that was a good one. All right, so for your turn, you got two things to try out. You got this crazy triangle and a hexagon on a semicircle, and you've got a little triangle inside of a circle shaded region one. Give those a shot and then come back to see how you did. All right, get things started here for our triangle. We should have done 1/2 base times height. That should have been 1/2 times 15 times 8, which is 60. For the trapezoid, we're doing 1/2 B1 plus B2 times H. That's 1/2 times 15 plus 12 times 8. What is that? That is 108. And then for the semicircle, we're doing 1/2 pi r squared. That's 1/2 times pi times 6 squared. And that is 56.5. So if we add those all up, 60 plus 108 plus 56.5, I am getting 224.5 centimeters squared. And then for the second one, let's see here, for our circle, we need to do pi r squared. And looks like we can use the 6 as our radius. So I'm going to do pi times 6 squared. That is 113.1. And then for the triangle, well, I guess if this is a 45, 45, 90, then this has to be 6, this has to be 6, right? So the entire base of the triangle is 12. Oh, I'm sorry, I didn't even write down the formula first. So triangle is 1/2 base times height. So this should be 1/2 times 12 times 6, which is 36. So we're just going to do 113.1 minus 36. And we will get 77.1. This will be centimeters squared. And there we have it. That is going to wrap this video up. Hopefully that went well for y'all.